Hello, this video is going to explain the first task that you need to do this week, which is in fact the only task you'll need to do this week. Here we have a diagram, and just blow it up a little bit. It's going to behave itself. There we go, of how to do a paper aeroplane. This is one of literally thousands of diagrams you could find on the internet. Your goal this week is to come up with your own experimental design where you are changing just one variable about the paper aeroplane. What's a variable? I'll give you a little time to have a think about all of the various things that you could change about the paper aeroplane and then come back. Okay, you've had a little think. So what things could you change? Well, there's heaps and heaps of things. I'm thinking about things like the paper thickness. So you could decide, I'm going to change the paper thickness. So that's one possibility. Another possibility that I'm thinking you might want to change is you might want to change something like the width, so that have it with narrower wings, or the height, or you might want to change the hole size, so not just the width or the height, but just have a smaller scale paper aeroplane so that your paper aeroplane looks like a miniature model of your other paper aeroplane, which is a bigger one. You might want to do things like, you might want to put weights on the end. So you might have paper clips that you put on the nose, or paper clips that you put on the wing to represent things like jets and a jet engine, or propellers and a propeller engine. You might want to instead put holes in the wings, or experiment with different shaped wings, keeping everything the same. So there's lots and lots of different things you might want to consider. But the idea is that when you consider them all, you're just going to change one thing. So if you're changing the thickness of the paper, then everything else is the same. Your paper aeroplane looks exactly the same. There is no difference at all. If you're changing the width is the only thing you change. Everything else about the paper aeroplane is the same. It's made this time out of exactly the same paper, no matter which paper aeroplane you make. Or the height. Again, with your paper aeroplanes, the only thing you change is the height. Nothing else. By height, I probably mean the length. That's a better word than height. Size. Again, you've got a smaller aeroplane and a bigger aeroplane, and the only difference is the size. So one aeroplane is an exact miniature of the bigger one. Same with the weights. You might have no paper clips on one, and one paper clip, two paper clips. You might go up 3, 4, 5 and have lots and lots of different paper aeroplanes. In fact, that's an easy one to change, because all you've got to do is to add paper clips on. You might go for different size holes. You might sort of put a single hole in it, 2 holes, 3 holes, see how you go. You can use a hole punch. There's a variety of different ways you could put holes in, or different shaped wings. You might have wings that stay flat, wings that curve up, wings that curve down. You've got lots and lots and lots of different possibilities. But the idea is that you, in making your series of paper aeroplanes, you're only changing one thing. And you may even think of something that's totally different from any of the things I've written up. And that is absolutely fine. Just check with the teacher that you're on the right track, but that's absolutely fine. And in terms of what you're expected to do, you're expected to take the paper aeroplane and at least test it. So at least get some measurements, and I'm thinking probably about 3 per paper aeroplane, so that you wouldn't just throw it once, you'd throw it 3 times, and the person that throws should always be the same, and the way it's thrown should always be the same. So the only difference that you are affecting with a paper aeroplane is the thing you are wanting to vary. If, for example, it's the paper thickness, then we would say paper thickness is the independent variable. That's the thing that you're changing, and the distance it flies is the dependent variable, because you're thinking that it depends on the paper thickness. In terms of writing up the experiment, the expectations are as follows. We need an experiment title, so we might call this a paper plane experiment. So I'll just go and get that written in now. There we go, paper plane, aeroplane experiment. We want the results for everybody, but this writing up is something we expect people aiming for the core level to do. We'll also put a date when it happened, which for you, I'm doing this on the 2nd, but I think you'll probably end up doing this on the 4th of, 11th I mean. I'll change it to 11. Pretend I'm change it to 11. Here we go, 11th of the 2nd, 2015. So, we need an aim, which is a general statement about the experiment. And then you will go and write in your aim here. We need your hypothesis, which is your prediction of what's going to happen. So if you think that the aeroplane, if for example you're changing the paper thickness, if you think that the aeroplane that is made out of cardboard will go further, then that's what you write in your hypothesis. Then we have the equipment. So you might want to think about the various bits of equipment. So here you would pop down the equipment that was being used. So things like what you used to build the paper aeroplane and what you used to measure how far the paper aeroplane went. That goes in the equipment. After the equipment comes the method. In the method, we're looking for two things. We're looking for how you made your paper aeroplane, and then how you tested your paper aeroplane. So in order to describe how you made your paper aeroplane, I'm thinking a really good way is by a series of diagrams. So the diagrams that you used when you researched how to make your paper aeroplane on the internet are going to be really useful here. So you might, for example, in your method put a 1 and then actually draw the diagram of the first step, and 2, the diagram of the second step, and keep on going all of the way through. So that might be a really good way to get that done. And then when you've drawn all of that, let's move everything away. When you've drawn that, then you'll be able to then, at the end, describe afterwards how you then, say we get up to step number 8, you might describe then how you tested the paper aeroplane. So the fact that you got one person to throw it and it was thrown exactly the same way, etc. Then you'll need to write up a results, which is going to list in a table form how your paper aeroplane was thrown. So I'll go on to the next page to give you an idea of what I mean here. Your results might look something like a table, and you might have, say you've got 3 paper aeroplanes, so you might have aeroplane number 1, aeroplane number 2 and aeroplane number 3. So you might have number 1 distance, which is for plane number 1. Number 2 distance for plane number 2, so you'll need to clearly indicate to us which plane number 2 is. Like, is plane number 2 the one made out of cardboard? Is plane number 2 the one with the longer wing or the smaller wing, so that we know? So that's something that you'll need to state clearly. And the distance 3, and then your attempt 1 and your attempt 2 and your attempt 3. And then you'll be able to then go and fill out the table. And if, for example, the first plane flew 2.72 metres, then you can get the 2.72 metres written down there. And then in attempt 2 it might be 2.51, and attempt 3 might be 2.87. And then you'll need to somehow get that into one number to compare, and a really good way is to work out an average. And the kind of average that we're going to learn this year. We're going to learn this new word called mean, and a mean is basically what you would call the average. So you would actually go and work it out by adding up these three numbers, 2.72 plus 2.51 plus 2.87, so that plus that plus that, and once you've got your total, which is going to be round about 7 point something, I think, somewhere, then you'll then divide that by 3 to work out your mean. Once you've done that, you'll need to write a discussion for your experiment that tells us things that you found difficult in the experiment, things that could be better, so difficulties, improvements, or improvements that you suggest. And the final thing you'll need to do is to explain. You'll actually need to explain why you think the one of the planes flew further, which may be the plane you predicted, it may not be the plane you predicted, but this gives you an opportunity to talk about and finally a conclusion. And just like before, your conclusion, which I'll put on the next slide, the conclusion will indicate whether the hypothesis was supported or rejected. So you will either choose one of those two words. The words that you don't want will be crossed out. We're just going, I've misspelt rejected. We'll just cross that bit off and change it to rejected. So if it was supported, then you will go and remove the rejected, get rid of that. And if it was rejected, you'll get rid of the supported. But that's what we expect to see at the end. Okay, good luck, and let's see whether your prediction worked or not. If it worked, that's great. If it didn't work, that doesn't matter either. What's interesting is that you have carried out the experiment and have come and reached a scientific conclusion. Good luck.